Welcome back, everyone. In this video, we are going to talk about a couple performance optimization hooks that React has given us access to. The first one I want to talk about is useCallback. And to understand useCallback, we need to understand how function declarations inside of a functional component work by understanding how React treats functional components. As I mentioned before, whenever you render or re-render a functional component, React is going to go through line by line of this entire function every single time. Hooks by nature are more optimized for this process, but any variables you declare. So if we were to hard code a variable, let's say ABC, which equals a string ABC, whenever this component renders or re-renders and it hits line 20, React is reinitializing this variable with this string. Now, with variable casting, this is pretty performant. It's extremely minimal and has very little cost. But when you take something more complex, like casting a function, this is definitely more expensive. Even with anonymous functions inside the return call, React is reinitializing this function every single time, including our named variables as well. These are also being reinitialized every single time. And the reason why this is happening is because React doesn't know whether or not this is something that is brand new or it isn't brand new, because it doesn't know if any of the scoped variables inside are referencing new values. React just operates in a way where it just behaves like regular JavaScript. I see a function definition, I'm going to define and initialize the function. So for us, generally speaking, this is not that costly. So this harkens back to what I was saying last video. Do not optimize your code if you don't need to. But let's say you're working on an application and you have hundreds of components that are rendering on the page, and each and every one of them is initializing a function every single time, and numerous of those are constantly re-rendering. In that case, these little performance bumps may improve your actual overall performance. So how does useCallback work? UseCallback is a hook that takes two parameters. The first is the actual callback that you want to memoize. And the second is a dependency array that determines when it's time to re-memoize this function. Now, when we talked about memoizing, we were talking about memoization with selectors. And the way that we memoized our selectors was that if the parameters do not change of that function, then you will always give you back the same output. That was memoization with selectors. Memoization in this context is that React is doing something similar. Essentially, this callback, it does not need to reinitialize. As long as this dependency array value does not change, then React will always give you back the same function. Not the return of the function, but the actual function itself. React is memoizing the function. React is not memoizing the output of the function. And that's a very key difference to remember. Because of the fact that React is memoizing this function, now React does not need to reinitialize this function every time it comes and hits line 20 on a render or a re-render. The only time it will is if any values inside the dependency array changes. Now here you'll notice that the dependency array mentions that you're missing a dependency, which is navigate. This is where it kind of talks more about understanding how React uses references to determine if this value is new. Inside of React, and most of the time with these third-party libraries that create hooks, when you think about this useNavigate hook, it's giving us some function navigate that we can use to navigate to different parts of our application. Generally speaking, unless the structure of your application is constantly changing from a route level in a dynamic manner, this navigate is going to be the exact same reference, which means that every time React renders or re-renders this cart dropdown component and hits line 18, this navigate, it's automatically going to know, oh, this is the same value. I don't need to get a new one from useNavigate. So as a result, navigate is never really changing. So you don't actually need to pass navigate into your dependency array on line 22. React doesn't know that though. UseEffect or useCallback most of the time, as we notice, we get a lot of these warnings, but they don't know that this reference is doing that. So as a result, React will give you a warning. There is a dependency that's inside that I'm not sure if it will or will not update. Maybe you'll get some errors if you don't include it. The problem with adding it, and it's not really a big problem, but it is a concern and why there's two camps on this. When you add this dependency, it kind of sends a mixed message that you can expect this callback to reinitialize this function, and that navigate is something that does change or can change or most likely will change. But this is actually not true. Generally speaking, we don't expect navigate to ever change. So this is where two camps sit on this topic. Some people say add it. As long as you understand that navigate is something that doesn't change, there's no harm in adding it. Other people say that it makes your code a little bit miscommunicated. It's saying that you can anticipate navigate to change, which is why I'm even adding it in the dependency at all. I'm expecting something to change. So again, this is where really it depends on the team and the person that's coding out your code. But the main thing to understand here at the very least with useCallback now, our function is memoized. We don't really need to add it to the dependency array. But now that we have this memoized function, we can now expect that this cost is not going to be there to reinitialize this function every time. But if you miss adding something to this dependency array, you may actually come with a couple bugs. And that's what we're going to talk about. And through talking about that, we'll also better understand what's actually happening with useCallback. So join me in the next video where we'll discuss that. I'll see you there.